the bath composition, and it is really a benchmark of our GAP members now, making 10 kilograms of dross per 10 coil, which means a dross make of 0.1%. That's where a number of our GAP members are today. We show here just one of the computer readouts from the Tech Cominco aluminum sensor they have, the electrolytic sensor, which is capable of measuring aluminum only. That's the nature of it. If you want to go to measuring magnesium, you need the LIBS technology to do that. So it's been mentioned about the challenges for the automaker. I won't go over this because Dr. Singh has already covered it. The die buildup, the need for overcoming powdering and galvanneal, and the welding electrodes, he's already well covered that. So we also needed to improve the coating weight uniformity, because it was very common in the old days, and still with many of the older lines, the vibration in the line and the variation in the coating thickness. This made it very difficult for the automaker to consistently form the steels. If the coating weight was variable, then he'd have thick coating in one location and thin in another. So to reduce the variability of forming performance, we really needed to use coating weight controls that are now based on feed-forward models, and we use hot gauges. We show here just a picture of a hot gauge directly above the pot. You can see it just here. Then this allows for a direct feedback. The sheet has only gone a meter or so before you understand its coating weight, and you go back and adjust the line's coating thickness rather than waiting it for it to go up the tower and another quite a few meters before it is normally measured on the normal lines. So this is a very important way of reducing variability. Also, weldability, of course, is very important, the coating weight variability, which you can do with these new coating weight controls. So that's also a very important part of the development of the hot dip automotive product, and the GAP program is a very important part of that, with the fundamentals of that. Turning now to the lightweighting challenge. It's been mentioned that high-strength steels are being introduced to meet the requirements. We see in the USA, it's the corporate average fuel economy of 54.5 miles per gallon. You can see on the chart the rise of this from the current high 20s, low 30s. We're now entering up the ramp, heading up towards in 2014. You can see we're climbing up that hill, and this is a real challenge to introduce lightweight vehicles that will allow this challenge to be met. In Europe, it's a similar hill they're climbing. They'll get to 95 grams per kilometer of emissions by 2021. That is an equally ambitious sort of number with the USA numbers. There's huge fines that are applied if the automakers do not meet these requirements. It's $5.50 US dollars per 0.1 miles per gallon under the standard, multiplied by the entire production of the fleet that they make in the US domestic market. So there are tremendous economic incentives for the automakers to meet this requirement. So the response of the steel industry, we've talked about some of these steels, has been the martensitic steels, the dual-phase steels, the transformation-induced plasticity or trip steels, and the complex phase steels. And to this now, we can add the press-hardened steels that are also coming along. So these are widely being adopted. We've seen here the growth of these in light vehicles. This has also been discussed before. And this is an example in the USA. We have the Jeep Grand Cherokee automobile, which was 29% high-strength steel in the mid-2000s, going to 50% high-strength steel in the 2011 Grand Cherokee, and moving up to high-strength steels further on as 70% as we go further into this decade. So this is just one example. We have many cars that are in this situation adopting these higher-strength steels, consistent with what's been said before. At the same time, we have global sourcing, and that is also a pressure on the Indian automobile industry because all these automobiles are now produced. They are looking for sources all over the world, and that will include, of course, sources for these steels here in India. So we show here the various manufacturing plants around the world for one model only, the Ford Escape. It is made in several locations around the world, in China, in Russia, and the Southeast Asia, in Vietnam, as you can see here, together with North America and Spain. So the Hyundai Sonata, another vehicle. We are seeing, of course, Hyundais here in India. I think it's one of the largest selling marques, and the use of advanced high-strength steels here. is also very important, and you'll see this continue to grow. The Hyundai is also, as was mentioned, a 100% galvanneal coated automobile. Being a Korean automobile, it's all galvanneal. So the steel industry has responded to the challenge by having a number of lightweighting projects. The most recent one is the Future Steel Vehicle program, and they show here the mass reduction that's possible using 97% high-strength steel and advanced high-strength steel. So we can expect this further growth in the use of these advanced high-strength steels to grow in the future. Nearly 50% gigapascal steels, that means 1,000 megapascals, getting up in that range, and the amount of lifetime emission reduction that's possible. And this is done without any cost penalty because we're using less steel. The steel we use is more expensive, but we use less of it, so there is no cost penalty. And of course, automakers are used to making steel-based cars, so this is something they are familiar with. They don't have to change to other materials, which we'll talk about in a minute. They have a design advisor online, and this is available to all to help us design vehicles in high-strength steel at worldautosteel.org. It's a very good way of walking through and seeing what is involved in redesigning vehicles in advanced high-strength steels. So another factor we deal with is life cycle inventory and life cycle analysis. And we have to be very careful about this when we look at the substitution of lighter weight materials. We show the mid-range carbon dioxide emission, and you can see that the production of the material itself is highly favorable for the steels as you get them into primary aluminum, and it is only primary aluminum that we'll be making automobiles out of in the aluminum-based cars, and magnesium and carbon fiber reinforced plastics, even higher greenhouse gas loads. And we see here the part weight that is made from them. We can certainly see lower part weights if we are non-steel, but the amount of greenhouse gas used to produce those is substantial. So the total amount of kilograms of greenhouse gas, including the use phase, is shown on the right side. So we have to be very careful how we use both the in-use life cycle analysis data together with the metals production, including a recycling credit for all of these materials. We have a potential with the lighter weight materials to have an overall higher greenhouse gas emission, and of course this will come at a higher cost compared with the steel-based automobiles. So how much weight reduction can steel provide? We show here the advanced high-strength steel content marching up the curve. We are today looking at second-generation steels. We have reached about a 15 to 20% vehicle reduction these days. As we are moving into the third-generation steels, which is the grade that we are now working on developing coatability processing for, we will see this march up to 25% as we go up to 70% advanced high-strength steel content. And there's been a recent breakthrough in the development of third-generation steels. These are the austenite martensite steels. We have found a way to, in the GAP program, of not only reaching the mechanical properties that are required, but also providing hot-dip zinc coatability of these steels, and that's not been shown before. So with the GAP program, the Galvanized Automaker Partnership, I've mentioned this, we have 19 global steel companies as members. Tata Steel is a member globally of this program together with a number of suppliers. The global zinc industry, Hindustan Zinc, and others are members of this program as well. And we work on the technology that's required to bring about the lightweighting of these cars to meet the future requirements while keeping the cars based in steel. And these have to, of course, be galvanized steel because of the thin gauges that we're now using. So I mentioned the third generation steels. This is the austenite martensite line, this blue dotted line as we see on the top line. And the 2 points we have already in the GAP program are indicated with the stars over here. These are where our steels are sitting, so we're way off the curve up here, but if we temper back, we can get it back in this range here. So we're following right along the predicted line that was really realized in theory in a GAP program back in the 1999 or 2000. We actually theoretically predicted this. Now we've actually proven that this is the case. You are following on this line. We've actually done this, and we can actually show that these are now zinc coated. And so there's not only academic confirmation, but it's going to lead to tons, which is the best possible thing for us. So simultaneously producing these coatings with the required properties and also the galvanizability means that we have to understand the surfaces of these steels. This is a typical surface oxide covered advanced high strength steel before it gets to the galvanizing line, and this is the surface that we really have to make galvanizable. So direct and indirect hot press forming, I don't think we've mentioned this very much. This is where you are heating a steel up to the austenization temperature. It is actually above the melting point of zinc, and we have to understand how to treat these to make the very high strength steels, but still with a zinc coating. I'll just skip through some of this. We have aluminized steel. Ken D'Souza mentioned yesterday about this. Zinc nickel is also being used, but aluminized steel is the process that has been brought to practice so far. There are some zinc coatings that are out there for indirect hot stamping. So the aluminum challenge, finally, we see until recently, the aluminum usage in vehicle bodies has been quite small. No vehicle of a high volume category has been made in a full unitized body. It's been the hang-on parts like the hood and the trunk lids, the doors that have come into the high-volume cars. This shows, for example, the BMW 3 Series, which has an aluminum hood. That's been in production for some years, but the basic body of the BMW, all of them, is in steel, and there's no indication that's going to change for some time. So there are cars that are out there that have been lower volume cars, like the Acura. That was the first one. That was introduced in 1990. It sold for 15 years, a total run during 15 years of 18,000. So you can do the math. That's just 1,000 or so per year. And it was discontinued, but it became a real cult car. They're wonderful cars to drive. After that, the Audi A8, that was introduced in 1994, a few years later, and they're selling 20 to 30,000 vehicles per year, which is still a low volume car. It's a higher end car, very expensive. But the chief engineer of Audi said at the end of last year that in view of everything, he did not see that aluminum was a future solution. He thinks that in view of the higher strength steels that we've been talking about here today, that aluminum is not a future solution for Audi, which was wonderful news for us, of course, to see that in their future. Jaguar XJ, we've seen tremendous market growth in the last year or so for the Jaguars. They've really come up from a smaller number, and I think you'll see a doubling of this 20,000 in the next year or so. They are now a full aluminum body. They've been so since 2013. They were very low volume back then, have really grown. And then recently the Range Rover, the 2013 Range Rover and Range Rover Sport, that was just introduced last year, pricing beginning at $83,500. So this means it's also a limited volume vehicle, a higher end vehicle. The Mercedes also, these sorts of vehicles are a few thousand annual sales. The Tesla is trying to produce 26,000 per year, and that'll have a aluminum body that replaces the carbon fiber body that they had before, which was even more expensive. So the aluminum industry is really trying to push this along. They see the airframes in the commercial airliners going to composites, the A350 coming up, the Boeing 787 Dreamliner already. So they are seeing, what are we going to do with all this rolling capacity? We're not going to make airplanes anymore. And so they've put a target on the automotive industry. They are investing heavily. Alcoa alone, we show here the $500 million or so they've put into the recent facilities. There's other companies like Novelis, Rio Tinto, and Rusal, and they've been putting the same sorts of numbers. So you have billions of dollars that the aluminum industry is putting in targeting the automotive market, and that is going to be to the detriment of the steel industry if that happens. The first high-volume vehicle we are going to see fully in aluminum body is the Ford F-150. This is the largest selling single model in the USA. There's 700,000 sold in 2013. That's more than the combined Toyota Camry and the Honda Accord sedan sales, which are also high-volume cars. And that's 40% of the USA truck market. This has already put a big scare into the USA steel industry, and we're making sure that we understand what's going on here. Ford has taken a huge charge to put this into production. They've already taken a $1 billion write-off to convert their lines from steel-based to aluminum-based vehicle production. We can see here the 1,000 pounds of steel, or half a ton of steel that's lost, and the 600 pounds of aluminum that replaces it. So this has been a huge challenge for Ford to go ahead with this. This shows some of these examples of conversions from galvanized steel. The roof rail, which these are the aluminum parts. You have similar geometries in steel, but this shows in aluminum. And one of the things they need to do here is adhesively bond these. They adhesively bond these. They are riveting them to just hold them together until the adhesive cures, but the main strength of these structures is going to be adhesive bonding. And this is much less convenient and much more expensive than the spot welds. It was indicated before, 3,000 to 4,000 spot welds per car is about what we're using today. This compares the aluminum lower cab structure. The black one on the right is the steel. The one on the left is the fabricated aluminum structure. And of course, the steel one is fully welded in a tubular construction, and the aluminum one is riveted and adhesive bonded. We'll have to see how it does. So we know that if we did not have this GAP program, we would be facing a loss of the zinc and steel market. We expect that without the GAP program, we would have lost 200,000 tons. With the work we've done to advance the high-strength steels that belong to be a real competitor to this, and I think this is going to be our future to face off aluminum with the higher strength steels that we've talked about introducing here. So. Just a few other things. Improving exposed quality has meant improvements in the bath hardware. We show here the sink rolls. We've been doing some modeling of this in the GAP program, and also the minimization of skimmings. This is the first data you'll ever see for the skimmings generation in a zinc aluminum magnesium bath. We've heard about zinc aluminum magnesium several times, and we show here that you have lower levels of zinc aluminum magnesium skimmings with air wiping or nitrogen wiping. This is in the range also of that few kilograms per coil. You can't avoid that. We have to understand that. We have to manage that and make sure we are producing high quality coatings with this. So the GAP program is operating in three areas, both in the galvanizability of all these new steels, in the improvements of the galvanizing line operations, and also with the characterization of coatings and the development of new coatings. So finally, we'll turn to the galvanized underbody. This is really a European development. There in Europe is a warranty requirement for underbody structures, anti-rust. This is the BMW M6. This is a stabilizer bar. This is fabricated and then galvanized after fabrication, just as we do with hot dip galvanizing. So this improves handling at speeds up to 300 kilometers per hour. And if you've driven in Germany, you've sometimes seen these guys fly past you, and this is the sort of stabilizer bars that they need for cars going that fast. So now they're durable. We know they'll be lasting a long time because they are hot galvanizing. There's also a product called MicroZinc. This is a Voigt & Schweitzer product. GalvaPower is the subsidiary, and this is now in series production. This shows a multi-link BMW suspension. This is a zinc 5% aluminum hot dip coating, and they've trademarked it MicroZinc, and this uses about a 15 micron coating thickness. So it's much lower thickness than our normal coating thickness that we would have on a hot dip galvanized part. It's not reactive to steel quality, so we can use silicon-killed steels and have no problem at all with the overcoating, and shows a very low corrosion rate. So this has been a very successful development for high volume use of general galvanizing in Europe. We also can make these parts out of continuous galvanized sheet. We are here again competing against aluminum. They are trying to get aluminum forgings into these underbody parts. This shows a lower control arm, and this is a clamshell design using the hot dip galvanized sheet from a continuous line being put together. This comes from the World Auto Steel program to make these kinds of very lightweight parts. And so in summary, I think I've shown, and I think you've seen here through these talks, that we see a real future for steel-based automobiles. Steel-based automobiles is going to be around for a very, very long time. It has the capability of meeting fuel economy and emission standards. It's very important that we all work to get advanced high-strength steels into automobiles. We also know that they need to have corrosion protection because there's really no corrosion allowance. We really have to have thinner sections for lightweighting, and they require good corrosion performance. Life cycle analysis, we show steel coated with zinc has the lowest impacts for combined production and also use phases. So overall, we see those sorts of numbers being very helpful for helping the environmental impacts. And we also have worked very closely with the steel industry, the zinc industry together. We've already delivered a lot of technical and economic successes that have allowed tonnage qualities to stay in these advanced high-strength steels, and we expect that to be the case for the future also, and we expect to fully meet this aluminum challenge. We have many more technical successes to realize, and I think we've got a longer and better road ahead of us than the aluminum industry does. So with that, I'll close, and I look forward to joining our discussion of all these papers. Thank you.
Thank you, Dr. Frank, for indeed enlightening us with the new value-added products which are being developed to help zinc and steel industry in maintaining their market share in the car and automobile market. We have also learned that high-strength steel will be one of the major initiatives which will be there, and steel industry has to take a challenge that how they can produce that much of high-strength steel, which is going to be a new requirement. We have also understood that how the GAP program is making an initiative towards improving the zinc-coated steel, and steel industries is being protected for the future challenges where the new products or the aluminum car bodies may come and may have a market share. It was indeed a very pleasant and excellent program which we had now. Now I'm keeping session open for the question answer session. I would like any of you to, if you have any question, please can ask. Volunteers, you can arrange mics.
Singh, Author, can you tell us what is the current GA capacity in Tata Steel and the roadmap for future expansions? And number two, what would be the tonnage of galvanized steel which Tata Motors would be using themselves?
Yeah, I think the first question was what is the current capacity, GA capacity? Yeah, the current GA capacity for Tata Steel is 0.3 million. So we have one galvanizing line, and if it is used 100% to GA, then it will be 0.3 million tons. The roadmap, we have a new plant coming up in Kalinganagar, which is the adjoining state of Odisha, and though it is not approved by the board as yet, but we plan to have 2 more galvanizing lines, and that is still on the drawing board but not gone into the board approval as yet. And out of those 2 galvanizing lines, one definitely will be an automotive galvanizing line. The other question on the galvannealed usage by Tata Motors, I can't give you the exact volumes, but definitely they use GA for Safari. The galvannealed is used in Safari. It is also used for Tata 207, which is the Xenon. And the other vehicles, yes, there is very little usage of GA for the underbody parts. But I'm sorry, I cannot give you the exact numbers on that.
Question for Maruti. We're very encouraged that we've moved from 5% to 20% GA in Indian automobile. But what would be the main lever? You know, there's still a big gap between domestic and export, which is at 70%. What would be the main driver for higher domestic use in India?
Actually, as I said, there will be 2-3 drivers for this. One is, of course, if the perceived quality of customer desires that we should give more and more value to the customer, then definitely this will drive. Second is the warranty requirements also going up. Now almost all OEMs are giving 2 years warranty. As the warranties improve going forward, if we extend to 5-year warranty or maybe more, then again the requirement go up. And third, definitely, what is happening is now we have two specs being made. One is for the domestic market, and the same vehicle, if it's exported, it's a different spec. But when you do this, you need to also, the production process has to be capable enough to handle both the things together. So this also, it leads to, of course, problems in managing both the things. So definitely the alignment with global will happen. We also see that next 3 to 5 years it will happen that Indian industry will also use more and more steel. Like for example, if I am saying today 15, down the line we think that it will go to 30, then 40, and then 50. That's how we see the trend going forward. And of course, that's how we look at things now. There is no clear roadmap that when we match with exports, but of course, gradually will increase. Thank you. I felt that very few people knew that there is some GA happening in the car. I think, of course, I'll pass this comment to my marketing team also, marketing session, that we should have some education programs for our customers that GA should be promoted. Actually, the trend is there now. If you look at, the safety is becoming very important in automobiles, and then definitely you look at the new models which are coming, there are more safety features are built in, and the regulations also coming. So it's all about what gains priority, because we have also need to prioritize things. There's a long gap between where we are today and where the exports are. So I think priorities will take some time for us to work on it.
Good morning. I have a question for Dr. Frank Goodwin. Sir, we talked about the LCA of zinc-coated steels, and also talked about how aluminum and parallel non-metallic materials have come into aircraft also, and even in automobiles. Regarding the fuel tanks the automakers use, sir. So we have seen a shift towards plastic fuel tanks, and the reason has been cited to be the weight saving needs. So how do you see this scenario unfolding in future, whether steels or galvanized fuel tanks can make a comeback in this market segment, sir? That was my question.
Yes, thank you. Starting about about 25 years ago, about 1990 or so, we saw a significant loss of application of steel in the fuel tanks. We saw plastic fuel tanks really take a large share of the fuel tank market away from coated steel, which had really owned that market up until the 1990s. And the reason for this was the trend towards the multi-fueling, the alcohol-containing fuel, and the steel fuel tanks at that time were not capable of meeting that requirement. So we did see fuel tanks being changed over to plastic. The one thing that has been turned out to be a real detriment for the plastic fuel tank is that there is no plastic fuel tank made that is completely permeable to the organics, the fuel. So you do have evaporation, you do have a emission really of the fuel evaporating through the plastic fuel tanks. And so this has had to be taken into account along with the emissions during actual use of these vehicles, especially in hot climates. In India, you certainly have fuel evaporating through the tank in a hot day like today. The steel industry has responded. It had a steel fuel tank initiative that started about 15 years ago, and that's been a very successful program for the lightweighting of these tanks and also their coating to be able to handle the multi-fuels that are now commonplace. So the steel fuel tank initiative has allowed a number of recaptures of existing markets from plastic fuel tanks back to steel. I think the continued improvement of design that's coming out of the World Steel program and its diffusion with the automakers will lead to a recapture of more market share of the plastic fuel tanks. They'll be returned to steel in the future.
Sir, you explained and shared with us that the currently around 20% of car body weight you are using as a galvannealed. So in terms of weight equivalent, how would much in kg that would be? And for your export, when you said that it's 70%, so what would be the equivalent in terms of weight? And second question is that from an automobile perspective, and if I have to talk about specifically from the Maruti Suzuki's strategic point of view, when one of the car maker, tell you like Volkswagen, is marketing very aggressively about using galvanized steel, 100% galvanized steel. So do you think then there is going to be a shift in Indian scenario as well, that going forward, galvanized steel usage in a car can become a unique selling point for you as a marketing agenda? Thank you.
Thanks for your question. If we try to convert into weight, it will be approximately between 40 and 50 kg per car is what we are using as input today for any car we are using, including this fuel tank which he said. That's what we are using today as steel, GA steel in the new models. Now the second question which you said that export and how quickly we'll get there. Actually, I said, there are a lot of things which we need to do today. When we compare the cars which are sold in domestic market with export, there are a lot of priorities coming up. You need to strike a balance. It all depends on what is required when. When we came out with this automated gear shifting, we also anticipated that it's a big demand for that kind of thing, and then we sold it, and now we're getting good numbers there. Similarly, now there's a lot of requirement coming for safety, there's a lot of requirement coming for, if you can say, ABS systems, there's a lot of requirement for GA. Ultimately, we also have to see that everything, whatever you do, it adds to the cost of the vehicle. So it depends what customer will accept and when, and what is our perception about the priority. Definitely, if there's a demand for GA, we can give it. We can always do it. But there's a huge cost impact today. Once you move from local to GA, the premium is also high if you add GA to any steel. And also, secondly, there's also that we don't have enough domestic capacity. If we depend on import, then FE fluctuation. So all these things we factor when we decide what we should do now and when. And since we are a mass provider, we have to be very careful about what we do in any segment.